Okay guys, so let's talk about separating mixtures. So we talked about classifying compounds, or classifying matter, sorry, and you can, you have two main categories. So you can classify matter into either a pure substance or a mixture. And then within the pure substance category you have elements and compounds. And within the mixture category you have homogeneous mixtures and heterogeneous mixtures. And so today we're going to talk about how you can separate the individual parts of mixtures. So how can we do that? And so what you're going to do is you're going to exploit certain things about mixtures. So mixtures can be separated because of the differences in physical properties of the components. So we're going to use those differences, we're going to exploit those differences to separate the different parts of a component. So what you have to do is you have to find a property that's different, some property that's different. So I could give you, for example, crayons, and you could separate those crayons physically and you could exploit a difference. So you could separate broken ones from not broken ones. You could separate them based on color shades, so all of the blue cool colors versus all the warmer tones, or the blues versus greens versus reds versus orange, just the primary colors and the shades of those colors, or complementary colors, or however you wanted to do it. As long as you could identify some difference between them, you could exploit that difference. And so that's what we do when we separate mixtures. We find some difference that's sufficiently different that allows us to exploit that difference and then just separate them. And so we're just going to talk about some various techniques. These are not all techniques. Some of the more popular ones that you may see around. There are a few here that I have here. This is not a very extensive list here, but we'll talk about more than this in the presentation. So a couple are filtration, distillation, and chromatography. Magnetism, density. Let's talk about some of those. And so the first one's going to be filtration. So what are we looking at with filtration that allows us to separate particles? Well, just think about it for a second. When you filter something, what is happening? Some particles pass through the filter and some particles are stopped by the filter. So what physical property are we exploiting? Well, what we're doing is we're exploiting the differences in size. Small particles pass through the small holes of the filter. Large particles cannot pass through the small holes of the filter. And so that's what we're doing. We're simply separating the particles based on size. We have submicroscopic holes in the filter. So here's our filter. This would be a cross section of our filter right here. And you can see we have these very, very tiny submicroscopic holes in this filter. And then we have these very tiny particles that can pass through, and the larger particles cannot pass through. And so that is what filtration does. It simply exploits size differences. Now you can buy filter paper with all different size holes in it. You could buy them with very, very small holes, medium-sized holes, larger holes, and based on what you're trying to filter, you could do all kinds of filtrations with properly sized filter paper. And if you're a scientist, you would know what size you're looking for, and you'll simply buy that size, the filter paper with that size hole in it. The next one that we're going to look at is distillation. This is a really cool process, and it's the one I'm going to show you is really simple, but there are very advanced forms of this. Distillation exploits the differences in boiling points of two liquids. If you have a mixture of two liquids, we know that if we heat liquids, they'll boil. What if they boil at different temperatures? Well, the one that boils at the lower temperature will boil away first. If we can then recapture that, then we can capture that liquid and we'll have the other liquid remain behind, and we have our two liquids separated. And so here is a simple laboratory setup of a distillation apparatus. It may not look simple, but this is a pretty simple distillation process. What you have is you would have your original mixture. Oops, let me back up. You would have your original mixture in the flask there on the left, and it would be your mixture. You would heat that mixture, and the liquid that boils first will boil away. Now notice the top is capped, and it can't escape. It's forced to go down this condensing tube that's attached to the top of the this is a distillation flask, and the liquid is forced to go up this tube or I'm sorry, not the liquid, the vapors of the liquid that we're boiling are forced to go up this tube, the gaseous form, down here, and there's this inner tube which is surrounded by this larger outer tube. And in this outer tube, you can see there's a water in goes here. We put cold water in here, and so this outer tube fills with cold water, which cools the glass that the hot vapors are traveling through, and those hot vapors would condense back into a liquid on the inside of that inner tube, and then they just drip out. They just drop out the bottom over here. So we boil it, turn it into a gas. As that gas travels through here, it condenses back into a liquid, and it drops out here, and we collect it. So we have one liquid over here. We end up with a second liquid over here. The one that's out here, the distillate is what we call that one, has a low boiling point. This one here has a higher boiling point, and we separate our two liquids. You may have heard the terms a still before. Bootleggers would make moonshine, and they make it with a still. It's just a distillation apparatus. Oil is distilled into all the different gases and oils and petroleum jellies and cooking gases and propane gases via a very advanced distillation process, but it is the basic same function. Chromatography is another method, and we will do some chromatography in class. It's really a cool little process. Chromatography uses differences in intermolecular forces. So intermolecular, between molecules, they sometimes attract each other and sometimes repel each other. They'll push away or pull together. So chromatography exploits that differences. It can be kind of complicated. It can be fairly simple in some cases, but it allows those differences to separate things as they pass through a media. So the particles, say they're passing through a media, the ones that are not, let me bring up an example of one. The ones that are not attracted would pass through very quickly. The ones that are attracted would pass through slowly. And so in this case, we have paper chromatography. And paper chromatography simply uses a piece of paper, which is made of cellulose, which has certain properties to it. And if the particles are attracted to the paper, they won't move very fast through the paper. If they're not attracted, they'll move quickly through the paper. And so you can see we can separate the ink color as green. Green is made of yellow and blue usually, and the yellow and blue move at different rates through the paper due to the differences in attractive forces. And so that's how paper chromatography works, and we will do paper chromatography in the lab. We'll probably do it a couple of times actually in a couple of different scenarios. There's also liquid chromatography. We'll do a liquid chromatography as well, where we're going to separate out Kool-Aid dyes. And there's gas chromatography, which we don't have gas chromatographs because they are quite expensive. Magnetism. If something's magnet, something else is not magnetic, you can separate based on magnetism. That's a very simple process or concept. Here's a picture of that being used in industry. And so this is a recycling plant where they recycle almost everything. And so this is a conveyor belt here at the bottom that's just going up towards the back of the picture. And this big blue thing here is a big gigantic magnet. And there's a conveyor, kind of hard to see, but there's a conveyor belt here that moves. And so as this recycled material passes through, anything that's magnetic will get sucked up and will stick to this belt, which is always moving, and the belt will run off over here, and at some point the belt will leave the magnet, allowing those magnetic materials to drop off in some other area. And so it's just using the magnetism of the trash here to pull out anything that's magnetic that may be valuable to recycle, and then they'll recycle that material, because usually metals are valuable for recycling. And this other stuff may be burnt, or something else may happen to it depending on what the other material is. So real simple application of magnetism being used to separate out mixtures. And then I think the last one we have is a centrifuge. A centrifuge separates based on different densities or density differences. So a centrifuge spins things. And so if you've ever been to the fair, where the state fair, like where you get in this little round tube and you get up against the wall and it starts to spin, and then they drop the floor out from underneath you and you get stuck to the wall, that's a centrifuge effectively. And so in a centrifuge, you stick something in it, in the centrifuge, it spins it around, it throws the heavier stuff further down, the lighter stuff sticks to the top, and it separates. And so one way that centrifuges are used is to separate blood components. And so your blood has lots of components. This is a real simplified version, but you can separate the red blood cells and the white blood cells and the plasma. by throwing it into a centrifuge, and they call it spinning it down. They'll spin it down. The red blood cells are the most dense, so they'll get thrown to the bottom. And the white blood cells will be on top of the red blood cells, and the plasma, which is the least dense, would be at the top of the centrifuge tube, the cuvette, or whatever they're using. And so that's how a centrifuge works. And you can centrifuge all kinds of things. Anything that has different densities can be centrifuged to separate the items of different densities. Okay, so that is our little lesson on separating techniques. We're going to do some of these in lab. Next week we'll do several of these. We'll do chromatography. We'll do paper and liquid chromatography. We'll probably do some magnetism separation and some other things as well, just kind of to apply them in the laboratory setting. So that is your lesson on separating mixtures.